Hey guys, Curtis here from Swindle Creative. Today we're going to be creating, by request, a character controller. This is highly expandable, and based on requests in the comments of this video, we will expand the character controller even further, adding functions such as ladder climbing, swimming, whatever you want, honestly. So let's get started here. I'm going to go ahead and create a floor for our character to stand on. I'm just going to use a cube and expand it in a few directions like so. I'm just going to search for a grid texture or something along those lines. Let's use this one. Just drag it on there. I'm going to give it a size of, I don't know, 10 by 10 should do the trick. Alright, so let's create our character. We're going to use a capsule, and we'll just stick it to the ground like that. And we're going to take our main camera and we're going to parent it to our capsule. We're going to head up to this gear here in the transform, and we're going to hit reset, and that's going to put our camera right in the middle of our character controller. We're going to just raise it up to around where its head would be if this capsule were a human person or whatever controllable character the player is controlling. Just like so. And now all we really need to do is, well, we're going to add a few components and then we're going to get to writing our script. So the first thing we're going to do is we're going to add a rigid body component, just like that. And under constraints, we're just going to freeze our rotation in the X, Y, and Z axes. And the reason we're doing that is just so that while we're moving around, we're not rotating in any way that we don't want to be. So we can close each of these because we don't need to look at them. And let's make a new component, and I'm going to call it the Swindle FPC for first person controller. And we will be making a third person controller as well in a upcoming video. So we're going to click create and add, and once that pops up we can get started. Here we go. I'll just make this full screen so it's nice and easy for you guys to see. I'll zoom in a bit here as well. Okay, so the first thing we can do is tidy this up a bit. I'm going to get rid of the comments, and we're going to get rid of the start function, just like that, and we don't need any of this, so I'm going to get rid of all of that. And we have a nice clean thing here to work in. So why don't we first define our variables. So the first thing we're going to need is a public, whoopsies, transform, and that's going to be our camera. And the next thing is our rigid body, which doesn't need to be public actually, because we could grab it. Let's not grab it at start. Let's just, for simplicity's sake, public rigid body, spelled it wrong. We'll just call it RB, just like that. Hopefully my terrible typing gives you guys time to follow along easier. I don't know, I'm probably just being hopeful. So next we're going to get a public float. And this is going to be our cam rotation speed, just like that. And we're going to set that equal to around 5, just like that, 5F for float. Next we're going to make a public float called camera minimum Y, and set that equal to -60F. And we're going to make a public float camera maximum Y, and that's going to be equal to 75F. So what we're saying right now is that our camera is going to rotate at a speed of 5, and it's going to be locked in the minimum and maximum of the vertical axis to -60 down and +75 up. And that's going to stop us from having a camera that can rotate in a full 360 degrees, which would look like you were doing front flips or something. So next thing we need to do is add a public float called rotation smooth amount. Actually, you know what? It would make more sense if we said rotation smooth speed. We're going to set that equal to 10. Now let's handle our like movement stuff. So public float walk speed. I see I've made a mistake, but I'll fix it in a second. And let's set this to 9. And I'll just fix this real quick. And then we're going to get a public float run speed. Set that equal to 14. And okay, so public float max speed, that's going to be 20. And the reason we need a max speed is because we need to control the method I'm going to be using for to add force to our rigid body is going to need to be clamped so that our speed doesn't get out of control when we're pressing both the vertical and horizontal inputs. So that's the purpose of the max speed. The next one is going to be a public float, and we're going to call it jump power. And let's make that 30. Okay. Next, public float extra gravity. So this is basically the reason we're doing this is because by default Unity's system's gravity is just not enough. Doesn't feel realistic, doesn't feel snappy. It actually feels very slow. So I like to do this. You know, you can change it in the settings as well, but if it's right on our character controller, we can kind of individually adjust how much gravity is being applied to objects in our game. And I really like having that amount of control. So that's why I do it this way. The next thing is a float. It doesn't need to be public. And it is going to be our body rotation X. And then we have a float called our cam rotation Y. I'm just making sure that I'm spelling everything right here. Okay, and then we have a vector 3. And this is going to be our direction intent X. And we have a vector 3 direction intent Y. Just like that. And two more things, I believe. We have a float for our speed, because our speed variable is going to change between our walk speed and our run speed that we've previously dialed in. And then down here we're going to have a public variable, a public bool called grounded. And sometimes other scripts that we're going to make later will have to like check if the character is grounded. So that's why we're making it public. So now inside of update, we're going to call some functions that we haven't created yet, but we are going to create. So actually, why don't we just go through the functions one by one, and then we'll remember to call them, hopefully. So the first function is going to be our look rotation function, just like that. So the first things we're going to do is actually lock our cursor so that it's not, you know, flying all over the place while we're playtesting our character. So we're going to say cursor dot visible equals false, and we're going to say cursor dot lock state equals cursor lock mode dot locked, just like that. So what that's going to do is stop the cursor from being visible in play mode. So I'm just going to write some comments here to help you guys. In case some of you are beginners, I want you to make sure that you know what's going on. So the first thing we're going to do is we're going to get the camera and body rotational values. Yeah, that looks right. So we're going to get our body rotation X that we kind of declared up top. And we're going to make it plus equal to input. Oh my god, I'm so terrible at typing. Sorry. Input dot get axis. And it's going to be mouse X. Here we go. Multiplied by cam rotation speed, just like that. And we're going to get cam rotation Y plus equals to input dot get axis mouse Y. And that is also going to be multiplied by our cam rotation speed right here. And then what you can do if you are OCD is make sure that all of your equals signs line up. You don't have to. I like it. I think it makes it look really nice. Just like that. You know, just it's nice locally to have ones that are close together be even. Doesn't matter in the grand scheme of things. Okay, so the next thing we're going to do, we are going to stop our camera. I don't know why I'm starting with capital letters, but that's okay. From rotating 360 degrees. So this is where we're actually going to lock our camera according to those values that we had earlier. So we're going to say cam rotation y equals mathf.clamp, and we are clamping our cam rotation y, and we are clamping it from our camera minimum y to our camera maximum y, just like that. So there's our clamp. So our camera will no longer be able to spin in 360 degrees. So now we're going to create the rotation targets and smoothly rotate the camera and body towards them. So I'm going to create rotation targets and handle rotations of the body and camera. Okay, so we're going to create a new quaternion, and we're going to call this cam target rotation, and that's going to be quaternion dot Euler, and so that's basically takes a vector 3 like that, and we're just going to replace the first one there with negative cam rotation y. Okay, so, and now we need to create one for the body, so quaternion, what's going on here? Come on. For some reason my suggestions are all messed up. Okay, it's not, doesn't look like it's doing me any favors here. Body target rotation equals quaternion dot Euler, and in this one we replace the y value, so the middle one, with our body rotation x, just like that. Okay, so the next thing we need to do is actually handle the rotations. So we're going to say transform dot rotation equals quaternion dot lerp. So we're going to smoothly move from our transform dot rotation to our body target rotation, and we're going to do that by time dot delta time multiplied by our I think we made a variable for this, right? Rotation smooth speed. Yep, perfect. And now we're going to say camera dot local rotation equals quaternion dot lerp camera dot local rotation to our cam target rotation by time dot delta time times rotation smooth speed, just like that. And now if we, in our update, if we call this function by typing in look rotation, just like that with the two brackets, and if we save and we get out of here, we go back into Unity, let it compile. It's doing this little loading thing down there in the bottom right hand corner. We're going to have to drag our camera onto the script and drag the object itself into rigid body to define the object with the rigid body. We're going to hit play. We should be able to look around. There we go. So we have a good looking script. We can only look that low, and of course you can change that value based on the camera minimum y. So if we set that to -90, we'd be able to look perfectly straight down. And if we set it to something like -45, we would only be able to look down about this much. So let's head back into our script and let's write our next function. So our next function is going to be our movement function. So for movement, the first thing we need to do is we need to make sure that our movement direction matches our, whoa, I don't know what happened to my speech just then. Our our movement direction has to match our camera's forward direction. So direction must match camera direction. So we got a little trick, a cool little trick to make sure that this works. So we're going to say our directional intent x is going to be equal to camera.right. And then we just have to fix a couple things. So directional intent x dot y equals 0, and directional intent x dot normalize, just like this with the capital N. It's going to call a little, oh, we need a Z there. There we go. It's going to normalize that for us. And we're going to do basically all of this same stuff. So we'll just copy and paste it. We're going to change these x's to y's. We're going to change camera.right to camera.forward on this one. There we go. So we now have our the intentional direction that we want to travel in. The next thing we're going to do is we're going to change our character's velocity in this direction. So we're going to say rb.velocity. Now this is kind of a long string of code. So try not to get, I'll try and make it super clear. So rb.velocity equals our directional intent y, okay, so our forward intent, multiplied by input.getAxis. Okay, now this is our forward one, so we're going to use vertical. So that's our up and down arrows, or our W and S keys, depending on how you're going to play your character. We're going to multiply that by speed. Okay, now we need to add our next, movement. So we handle our forward backwards direction. Now we're going to add our side to side direction. So plus directional intent x side to side multiplied by input dot get axis horizontal multiplied by speed. And we are going to now add our final direction, which is just going to be vector 3 dot up, and we are going to multiply that by the rigid body's velocity dot y. So we're just going to basically keep our velocity up and down the same. And now all we need to do is clamp our velocity within our max speed. So we're going to say rb.velocity equals vector 3 dot clamp magnitude, and we are clamping our rb.velocity, and we are clamping it by our max speed, just like that. All right, so now if we call movement up in the update function right here, movement, oh, whoopsies, hang on a second. Movement, just like that, don't forget the brackets. Save it and head into Unity. Let it compile again. And once it has, we should be able to hit play and start moving around. Except for we can't, because our speed value is 0. So we need to make sure that we're actually setting our speed properly. So what we're going to do is in our movement function here, we're going to control our speed based on our movement state. So we're going to say if input dot get key, where's key, dot get key, key code dot left shift. So if we're holding the shift button, then speed equals run speed. And I'm just going to copy and paste this down like this. We're going to add a little exclamation point right here to say if we're not holding down our left shift key, then we're going to say that we are going to be moving at our walk speed. So now if we head into Unity, after saving, if we head into Unity and let it compile, we should be able to hit play and we should be able to move around and sprint and look around. So here we go, moving around. There's our sprint. It's nice and smooth, everything works really well. Just so that it's clear how we're moving around, I'm just going to give us a little bit more space like that, and I'm going to just give us like a wall back here, something like that. Maybe I'll even give us another one. Oh, I did not realize that was at an angle. Okay, I guess we'll fix this one too. There we go. So now it should be easier to see what's going on when we're moving around. There we go. So next thing we need to add would be what? Probably ground check, I would think. Let me think. No, because our gravity is still... So Unity has this thing where rigid body gravity is like really weak, and so mathematically it should be a replication of real life, but it very much isn't. So we're going to create a little bit of extra gravity just to make it feel a little bit more snappy. So new function, void extra gravity, just like that. So what we're going to say inside of extra gravity, it's one line of code. It's super easy. We're going to say rb.addForce. It's going to be vector3.down times, and we've already made this variable extra gravity, just like that. And now if we call it inside of update, right here, extra gravity, then it's already working perfectly for us. So the next thing we're going to do is we're going to create a ground check to make sure that we're grounded. So we're going to say void, whoopsies, ground check, just like that. And in here we're going to make a raycast hit. We're going to call that ground hit. We're going to say grounded, which is our bool that we've already made, equals physics.raycast, just like that. And we're just going to say so it's going to come from our transform.position, and it's going to be moving in downwards, so minus transform.up, so that's down because transform.down doesn't exist. We're going to say out grounded ground hit. There we go. And we're going to send our array length to 1.25f, just like that. And that should give us an accurate representation of whether we're grounded or not. So let's just make sure that that is being called here in our update, wherever update is, here it is. So we're going to call ground check, just like that. And now we need our actual jump. So void jump. Here's our jump function. So we're going to say RB for rigid body dot add force. It's going to be vector3.up times jump power, and it's going to be force mode dot impulse, just like that. So now all of that's taken care of. We have really just one thing left to do, which is call our jump. So it's the only function that's going to be called a little bit differently. So we have to say if grounded and input dot get button down jump. So if you press jump and you're on the ground, then and only then we can jump. And with that, we'll hit save, head into Unity, and our character controller, made 100% from scratch, should be pretty much ready to go and completely usable. So here we are. Here we have movement in every direction. Here we have our jump. Here we have our running jump. I'll just go ahead and create some obstacles and stuff for us to jump on. So let's just zoom in here. We'll make some sort of platforming little thing here. So we'll copy this, something like that, I guess. And then one other thing we can do is we can test how it works on slopes. So I'll just do something like that. And we'll just jump around a little bit. So here's a slope. We can stand on it. We can move up and down it easily. No jitter going on. Here's some simple platforming. So yeah, there's a custom character controller. Hope you enjoyed. And you know what? Like on this computer, the mouse look script is a little bit hard to control. So what you can do is you can just go into the settings, and I'm going to set my smooth speed to something like, I don't know, like 15, and I'm going to choose my mouse rotation speed, camera rotation speed to 4. Something like that feels a lot better, a lot easier to control. That feels really good. So anyways, I hope you guys enjoyed this video. I hope that it's helpful, and I hope you look forward to future videos where we expand on this concept. Make sure you leave comments telling me what you'd like to do, what you'd like me to show you how to do with this specific character controller. What functions would you like to see? Wall running, double jump, like let me know and I'll take care of it. I know how to do all that stuff. So just tell me what you're interested in. And don't forget to throw a like on this video and subscribe if you're new to the channel. Thank you so much for watching, and I'll talk to you guys next time.